Soil and water quality monitoring system for smart agriculture. It is a quite interesting project for electrical, electronics, computer science, engineering, and diploma level students. The hardware requirements are ESP32 microcontroller. You can use different microcontrollers. For example, Arduino also you can use. Capacitive soil moisture sensor, soil NPK sensor to measure the soil NPK levels, turbidity sensor, TDS sensor to measure the TDS level of the water, and a GPS module. Instead of GPS module, you can also use a IoT module as per your requirement. So LCD display and the power supply unit. You can see the water quality and soil quality indices. Going to the block diagram. So basically there is a processor ESP32 we have used. You can use different basic microcontrollers is more than sufficient for this project. We have a 6 set of sensors, 3 for measuring soil quality and 3 for measuring the water quality. Sorry. The soil NPK sensor, as you can see, it is the costliest sensor among all. It ranges from somewhere like 4,000 to 10,000. If at all you can have it, or otherwise you can just skip that sensor and uh, you can keep it optional. There is a GPS sensor. The main motto of this particular project, it is to measure the soil and the water quality at a different levels online. You can just carry with this particular device at different locations and you can just measure that, and you can just tag with the geo map also. So in the secondary side we have a communication modules. You can use uh, IoT here. Okay, by using the IoT, there is an IoT cloud. So through IoT cloud, you can develop in the secondary side, you can develop a mobile app, or otherwise you can just use a website also. Or otherwise, if your budget is less, you can just have a display. So simply, it will display these constraints, 6 constraints in the LCD display. So you can see the PIC microcontroller, sorry, ESP32 microcontroller. The price range is around 500 to 700. You can just have different basic microcontrollers for your application. So soil moisture sensor, so 100 to 300 rupees range. Temperature sensor, the price range is 100 to 300. The soil NPK sensor, as I told earlier, it is the costliest one. The range starts from 4,000, may go up to 10,000 and above. If you have a budget, you can keep this, or otherwise you can just skip this soil moisture, soil NPK sensor. So you have a soil turbidity to measure the turbidity of the soil. So water TDS sensor, it will measure the TDS of the water, and the GPS module to show you the GPS location where exactly you are measuring. Later you can just tag this with the GPS map also. LCD display, simply you can just measure all the inputs and you can display them one by one in the LCD display. And the power bank, normally everybody will have your own power bank, so you can reduce this cost also. If at all you don't have, you can just purchase for the power supply. The software requirements are the key is required to program the microcontroller. So basic programming knowledge is more than sufficient, because you have to just measure the input values from the sensor. There is no computation to be made here. Measure the inputs, just send it to the LCD display or to the communication channel. Through that communication channel, you can just send the data to the cloud. From the cloud, you can just prepare a mobile app, or otherwise you can prepare a web page also. So you can see that there is a login page here. So where agriculture officers and the agriculture farmers also can log, and they can just check the water and soil quality at different places in their particular range. And there is a chatbot also given in the right side corner here. Through that chatbot, the officials and the farmers can communicate for load shedding, for different nutrients and different diseases coming across their agriculture land. So those people can communicate with the officials also. There is a two-way communication through this channel, where officials can communicate with the farmers and they can plan for the coming agriculture Next is the implementation. You can see that different sensors you can observe, okay, inserted inside the water and the soil to measure the moisture and all. This is the most simplest project. Easily and quite effectively you can with very minimum effort you can just make this project for your college. So please like and subscribe for such interesting projects in the future.